Morning everybody, hope you're all healthy and safe. Today we shall begin with a new section 2.4 on the type of integral differential equation known as the exact differential equation. So in previous classes and all, we had discussed about separable differential equation and linear differential equation. So in today's lecture we shall study about what is meant by exact differential equation. So the definition is as follows: a differential expression m of xy dx plus n of xy dy is the exact differential in the xy plane if it corresponds to the differential of some function f of xy. Okay, so we say that an expression, it is an exact differential is actually an expression. That expression, that is this m of xy dx plus n of xy dy, this is said to be exact differential if this is nothing but the differential of some particular function f of xy. Okay, this is also same, it is like a first order differential equation. M of xy dx plus n of xy dy equal to 0 is said to be an exact equation if the expression on the left hand side is exact differential. So first definition was about exact differential, and the next definition is actually what is meant by an exact equation. Okay, so m of xy dx plus n of xy dy equal to 0 is said to be an exact equation if m of xy dx plus n of xy dy is an exact differential. Okay, so there is an example, that is, for example, x square y cube dx plus x cube y square dy equal to 0 is an exact equation. Now what is the can you guys guess the function? What will it be? That is, what is f of xy? What is f of xy such that this equation is a differential of f of xy? So I'll say if f of xy is equal to, say, 1 by 3 into x cube into y cube. Okay, what will be the differential of this with respect to x? It will be 3x square into y cube, so 3 and 3 will get cancelled, so it will be x square y cube dx, right? And with respect to y, it will become x cube y square dy. So this is an exact equation. Why? Because it can be written as this left hand side can be written as the differential of this function, right? So I hope the concept is clear. So an equation or a differential expression is said to be exact if it can be expressed as the differential of another function. Okay, so next is an important theorem. It is actually the condition that tells us or helps us to check whether a given differential expression is exact or not. Okay, so it's very important. So the theorem is as follows: let m of xy and n of xy be continuous and have continuous first partial derivatives in a rectangular region R, defined by the region is given, that is a less than or equal to x less than or equal to b. Sorry, this is not less than equal to, this is a comma. C less than equal to y less than equal to d, that is, we are considering a rectangular region. A necessary and sufficient condition that the expression, differential expression m of xy dx plus n of xy dy is exact is that the corresponding partial derivatives, that is dou m by dou y, should be equal to dou n by dou x. So this is something that you have to keep in your mind, that is dou m by dou y equal to dou n by dou x. Okay, so let us just see a small simple proof of the same. So it is simple, you just don't have to go deep into it. Let's just begin. So first of all, what I'm going to do is I'm going to assume that the equation is exact. So there's a necessary and sufficient condition, so we have to prove both the things. So suppose m of xy dx plus n of xy dy is exact. Then what is it we have to prove? We need to prove that dou m by dou y equal to dou n by dou x. Okay, let's see. Now given this expression is exact, therefore I can write m of xy dx plus n of xy dy as the differential of a function, say f of xy. Okay, so this differential will be nothing but dou f by dou x into dx plus dou f by dou y into dy. Okay, so let me compare the coefficients on both the sides. So dx and dx, comparing the coefficients or equating the coefficients, comparing the coefficients of dx and dy, what do we get? We get m of xy is equal to dou f by dou x and n of xy is equal to dou f by dou y. Okay, so let me take dou by dou y of n. This is nothing but dou by dou y of dou f by dou x, that is dou square f by dou y dou x. And again here what I'll take is dou by dou x of n. This will be dou by dou x acting on dou f by dou y. This is again dou square f by dou x dou y. Now in the theorem it's given that m and n have continuous partial derivatives and all, so both these must be same. The order does not matter. So we can easily say that as dou square f by dou x dou y and dou y dou x are same, I get dou m by dou y is equal to dou n by dou x. So if the equation is exact, then dou m by dou y is equal to dou n by dou x. Okay, now let's see converse part. Converse is it is actually like the method of finding the solution. So conversely, suppose that dou m by dou y equal to dou n by dou x. Okay, then we need to show that the expression is exact. Okay, so I have, if this is true, if dou m by dou y is equal to dou n by dou x, then we have dou f by dou x is m of xy. Okay, so dou f by dou x is equal to m of xy. So let me just integrate this expression. Okay, integrating, what do I get? Integrating with respect to x. Okay, so I get integral of dou f by dou x is nothing but f of xy itself. F of xy will be equal to integral of m of xy plus an integrating constant. So here that constant is treated to be like, say, some function of y, because we are integrating it with respect to only x. So m of xy is a function of x and y, so we'll have integral of m of xy plus some function of y. Okay, now what I'll do is I'll partially differentiate this expression with respect to y. Okay, So this implies dou f by dou y will be nothing but dou by dou y of integral of m of x by dx plus differentiating with respect to y, g of y will be g dash of y. Now as our condition is, as we have assumed that dou m by dou x is equal to dou m by dou y, this is nothing but n of xy. Okay, n of xy is dou by dou y of integral m of xy dx plus g dash of y. Now rearranging, I get g dash of y is nothing but n of xy minus dou by dou y of integral of m of xy dx. Okay, so next step is again to remove this differential, I integrate it. So integrating the above expression, we get g of y, right? Integral of differential is the function itself, so we get g of y. Now what was g of y? G of y was the constant in the expression of f, right? So we have f of xy was, in the very beginning we had done, it was integral of m of xy dx plus g of y. So here we'll substitute the value of g of y, that is nothing but integral of n of xy dy minus integral of dou by dou y of integral of m of xy dx. So this is the required function, that is the expression m can be written, or mxy dx plus nxy dy is equal to this f of xy. Okay, so this is the proof of the theorem. So you don't have to, you just have to go through the what is the main criterion or main idea for the condition for the differential expression to be exact. That is, dou m by dou y should be equal to dou m by dou x. That is something that we have to keep in our mind. So the proof is simple, you just have to follow it step by step. So now let's we shall see, this is how we can apply this to find the solution of a differential equation. So now though we are mainly focusing on the solution of the given differential equation. So suppose the differential equation is exact, then how can we check whether the or how can we find the solution of that differential equation? So suppose a differential equation is given to us and we are asked to find the solution. First of all, check whether the differential equation is exact using the previous theorem. Okay, so if the differential equation is exact, then what we do is then dou m by dou x, dou m by dou y will be equal to dou n by dou x. Okay, that is the condition to be checked. If that is true, then the solution is as follows. That is, we have m and we have n. So integrate m with respect to x, keeping y as a constant. Okay, remember that y is a constant here. So we integrate m with respect to x, keeping y as a constant. That was the first thing that we did in the proof also. And then integrate n of xy with respect to y, removing every term of x. Okay, all the terms of x must be removed, and then whatever is remaining, just integrate that term with respect to y. Then just sum them up and equate it to 0. That will be the required solution. Okay, so just doing a few examples will make the concept a little bit more clear for you people. So let's just work out a few examples which are given in your textbook. So first one is, we are asked to solve 2xy dx plus x square minus 1 dy equal to 0. So this is the expression given to us. First Identify what is m of xy. M of xy is nothing but 2xy. And what is n of xy? N of xy is nothing but x square minus 1. So let us determine what is dou m by dou y. That is nothing but 2x. And what is dou n by dou x? That is again 2x. So both are same. So therefore dou m by dou y is equal to dou n by dou x. Hence the differential equation is exact. So what will be the method of solution? So I'll tell you what is the procedure to do. We have m. What was m? M was 2xy and n was x square minus 1. What is the solution? The solution is integrate m with respect to x, keeping y as a constant. So here we'll have two constants, one is 2 and y. 2y is a constant, so integration of x is what? X square by 2. So we have to integrate m with respect to x, keeping y as a constant. So what will that value be? It will be x square by 2 into 2y. 2y is a constant, so 2 and 2 gets cancelled, so we'll get the term x square y plus integrate n with respect to y, removing terms of x. So here what are the terms of x? X square is a term of containing x, so we don't have to consider that. We just have to consider minus 1. So what is the integral of minus 1 with respect to y? It is nothing but minus y, and put that is equal to, say, some constant, or say equal to 0. So x square y minus y is the corresponding solution. This is how we determine the solution. Okay, let's do another example which is given, that is e raised to 2y minus y cos xy dx plus 2x e raised to 2y minus x cos xy plus 2y into dy is equal to 0. So this is a big equation. Okay, so this is of the form m dx plus n dy is equal to 0. So here m is nothing but e raised to 2y minus y cos xy, and n is 2x e raised to 2y minus x cos xy plus 2y. So let us find out what is dou m by dou y. Dou m by dou y will be nothing but e raised to 2y and minus y cos xy. Okay, so dou m by dou y will be 2 into e raised to 2y and y cos xy. So here we have to apply the product rule. So this will be minus cos xy minus that is the derivative of y is 1 and derivative of cos is minus sign, so it is x y sin xy. Okay, so this is dou m by dou y. Now let us see whether it is equal to dou n by dou x. Now dou n by dou x will be, what was our n? N was nothing but 2x e raised to 2y minus x cos xy plus 2y. So differentiate with respect to x, right? So differential of this with respect to x is nothing but 2 e raised to 2y, and here again the product rule. So it will be minus cos xy and cos, the differential of cos is minus sign, so it will be minus minus plus, and we'll have xy cos xy, and 2y is a constant here in case when we are differentiating with respect to x only, so this will become 0. So dou m by dou y is equal to dou n by dou x. Okay, so there's no problem in it, and hence the equation, the differential equation which is given to us is exact, right? So what will be the solution? So the solution, let me just write down. That is, we have to integrate m. I'm just going to write m again once more here so that it is easier. E raised to 2y minus y cos xy. So integrate m with respect to x, keeping y as a constant. So first term, what will be the integral? This whole term is a constant, so the integral will be x into e raised to 2y. Okay, and the next thing, y is a constant, cos x, what cos xy, what is the integration? Integration will be sine of xy divided by y. So y and y will get cancelled, so we'll get minus sine xy. Okay, so that is the integration of m with respect to x, keeping y as a constant. Now let's move to n. We have to remove all the terms containing x, so this need not be considered and this need not be considered. We have to just integrate this term with respect to y. What is it? Y square by 2, 2 and 2 gets cancelled, so this will be nothing but plus y square plus some constant equal to 0. So this is the required solution. Okay, so first what we have to do is we have to check whether the given expression is exact, and if it is exact, this is the method to find the solution. That is how to determine the value. And in some cases we'll be given initial value problems also, that is, we'll be able to determine what the c is. Okay, once we know that this is equal to 0, we can easily determine corresponding to, we know what is an initial value problem, so we'll be able to determine c with the help of the initial value also. So this is actually how we do find the the solution of the particular exact differential equation. Okay, so what are the method? The method is, first of all, check whether the differential equation is exact. Okay, if it is exact, then integrate m with respect to x, treating y as a constant, and integrate n with respect to y, excluding or removing all terms containing the term x. Okay, so this is the method of solution of an exact differential equation. So I have been repeating that this is applicable for checking for or finding the solution of a exact differential equation. So what happens if the differential equation is not exact? Okay, so that is where this concept of integrating factors come into existence. Okay, that is, sometimes the given differential expression or differential equation is not exact, but we will be able to make it exact by multiplying the expression with a suitable function, and that particular function is called as the integrating factor. Okay, so let's see, the same idea sometimes works for a non-exact differential equation, m of xy dx plus n of xy dy. That is, it is sometimes possible to find an integrating factor mu of xy, so that after multiplying the left hand side, that is mu of xy into m of xy dx plus mu of xy into n of xy dy will be equal to 0, will turn into an exact differential equation. So multiplying the differential non-exact differential equation by the integrating factor, we will get a exact differential equation, and once we have an exact differential equation, we know how to find the solution, right? Okay, so these are the two methods of finding the integrating factor. That is, first of all, we have to determine what is dou m by dou y and dou n by dou x. That we have to do in all. If you see any differential equation of this particular form, Okay, or if you can transform any differential equation into this particular form, first of all check whether it is exact, that is dou m by dou y is equal to dou n by dou x or not. Verify that. If it is exact, then go with the method. The procedure is simple. If it is not exact, try to find the integrating factor. If you are able to find the integrating factors, well and good. Otherwise we have different methods which we'll be learning further. Okay, that is the first one is, so we have determined what is dou m by dou y and dou n by dou x. So first, if my minus nx, that is nothing but dou m by dou y and dou n by dou x. So if my minus nx whole divided by n, okay, whole divided by n is a function of x, then the integrating factor will be x alone. There should be no y in it. Okay, then the integrating factor will be mu of x is equal to e raised to integral my minus nx whole divided by n into dx. Okay, that is this function of x alone integrated with respect to x and take the exponential. That will be the integrating factor. Then once we have the integrating factor, multiply the expression with this and you will get that expression is exact. Now the next one is, if nx minus my by m is a function of y alone, then the integrating factor is mu of y is equal to e raised to integral of nx minus my by m into dx. Okay, so these are the just simple formulas that you have to keep in mind. My minus nx divided by n and nx minus my divided by m. So the first one, when we are dividing it by n, if it is a function of x alone, then that we'll consider it as a integrating factor will be e raised to integral of that function into dx. And if the division, that is nx minus my divided by m, division is by m, it is a function of y alone, then the integrating factor is mu of y. So you can see, what do we calculate for the checking the exactness? It is dou m by dou y. So in the denominator, if it is m, then it should be a function of y alone, and in denominator, if it is n, it should be a function of x alone. So you can find some simple ways or methods to just remember this rather than memorizing it as it is. So just find some link between the theorem and this condition to determine the integrating factor. So I'll just show you an example which is in your textbook to help you understand or how we can determine the integrating factors. So the differential equation given to us is xy dx plus 2x square plus 3y square minus 20 into dy. So here m is equal to xy and n is equal to 2x square plus 3y square minus 20. So seeing itself, we can understand that dou m by dou y is not going to be same. Still we shall check what is dou m by dou y, or let me write my. My is nothing but, we get it is equal to x, right? Integrating this with respect to, differentiating, partially differentiating m with respect to y. So we get this is equal to x. And what is nx? Nx will be nothing but, we have to differentiate this. So this will be x 4x plus all these things will be constant, right? So we get this x and 4x. My is equal to x and nx is equal to 4x. So clearly dou m by dou y is not equal to dou n by dou x. Hence the differential equation is not exact. So first let us determine whether we will be able to understand or whether we will be able to find out the integrating factor or not. So let us determine first my minus nx divided by n. N means it should be a function of x alone, right? Function of x alone. Okay, so what was my was x, and this was 4x. What is n? N is a very big term. 2x square plus 3y square minus 20. So clearly we cannot simplify this to form a function of x alone, so this is not our integrating factor. So let's try the other expression, that is nx minus my by m. When it is division by m, it should be a function of y alone. Okay, let's see that. So this is nothing but 4x minus x whole divided by, what is our m? M is xy. So there is a possibility, right? 4x minus x is 3x by xy. X and x gets cancelled, so we get it as 3 by y. So here we have our corresponding integrating factor. So the integrating factor, just writing the short form, if, is mu of y is equal to e raised to integral 3 by y dy. So integral of 3 by y is nothing but e raised to 3 into log y. So this can be written as e raised to log y cube. So this is nothing but y cube is our corresponding integrating factor. Hence x into y cube dx plus 2x square plus 3y square minus 20 into y cube dy equal to 0 is exact. So you guys can just verify it if you want to, but it is exact. So what will be the solution of this differential equation? I'm just writing it over here. Or let me just take a new page. So m becomes, the new m is nothing but x into y raised to 4, and n is nothing but 2x square y cube plus 3y raised to 5 minus 20y cube. So the solution is integrate m with respect to x, keeping y as a constant, so that will be x square into y raised to 4 by 2, integration done, plus integrate n with respect to y, removing terms of x. So this is the only term which will be removed. We have to integrate these two terms. So that will be nothing but 3 into y raised to 6 by 6 minus 20 into y raised to 4 by 4 plus c equal to 0. And we can just simplify it, or we can just simplify it. So this is x square y raised to 4 by 2 plus y raised to 6 by 2 minus 5 y raised to 4 plus c is equal to 0. So this is the corresponding solution of the non-exact differential equation. So this is how we use the concept of integrating factors to find the solution of a differential equation which is not exact. Okay, so just remember these formulas, then we'll be able to transform a given non-exact differential equation to an exact differential equation. So we shall be doing more problems which will help you to just keep all these things in your mind clearly. So that's it for today's session. Thank you. Stay safe and stay healthy.